So this is another question, right? In which we are given that x is greater than y square is greater than z to the power 4, and we are given three parts: x is greater than y greater than z, z greater than y greater than x greater than z greater than y, and we are asked to select all of the parts which are applicable or which are valid. Okay, so again, this is a very important question, and through this question, we'll come uh, and arrive at some kind of formulas which you should learn. Okay. So, for example, firstly, if there is a thing given as a greater than b greater than c, right? This automatically means that a is greater than b and b is greater than c. This automatically means this, and also and a is greater than c, right? So if a is greater than b greater than c, this means a is greater than b and b is greater than c, and obviously a is greater than c. So I hope this should be completely fine, right? So let's take the case of x is greater than y square. Okay, so for example, now we have to prove that in this case, if x is greater than y or x is less than y, if x is greater than y square is given, we have to find if x is greater than y or if x is less than y. So again, let's assume that, for example, if x is equals to 2, right, and y is equals to 3, or actually you can write it as x is equals to 4. Okay, so if x is equals to 4, y is equals to 3, so x is, you can write it as actually 1. Okay, so x is greater than y square means 4 is greater than 1 square, which is 1. Absolutely right. Okay, so in this case what happens, that x is greater than y, right? X is greater than y, so this is a possibility. Okay, right. Now for example, let's take x is equals to maybe 1 by 2, right? And y is equals to 1 by 3, right? In this case, x, which is 1 by 2, right? Or actually, let's do one thing. Let's take this as x is equals to 1 by 3 and y is equals to 1 by 2. Okay, this is the right one. See, again, even right now, I don't know what value should I take, so I'm thinking. And when I thought, I had initially thought something wrong, but now I think this should be fine. So in this case, 1 by 3, right, is greater than y square, which is 1 by 4, right? Which is absolutely perfect, because 1 by 3 is greater than 1 by 4, because if you multiply 4 over here, so this side becomes 4, this side becomes 3, so 4 is greater than 3. Again, so 1 by 3 is greater than 1 by 4, which is very clear. So these values are fine, I mean valid. Now we have to see, in this case, if you see, y 1 by 2 is greater than 1 by 3, which means y is greater than x, right? So if this is the question, if this is given in the question, that if x is greater than y square, right, that means x can be greater than y or x can be less than y also. So both possibilities are there. So this is kind of a formula which you should learn, that if x is greater than y square, then x greater than y, x less than y, both are possible. Okay. So now let's come back to the question, right? So basically, if this is given, this means this is also possible and this is also possible. Okay. Similarly, for y square is greater than z to the power 4, if we talk about y square greater than z to the power 4, right? For this part, if you just take the root on both the sides, this becomes y greater than z square, exactly like this. So in this case, we can also say that y greater than z and y less than z, both are possible, right? I hope this should be fine, because if you, for example, take the square root on both the sides, this becomes y, this becomes z square. So exactly of the same format, right? So we can say if that y can be greater than z and y can be less than z, right? Okay. So this is a kind of formula which you should kind of learn, that if this is given, these two are possible, and if this is given, these two are possible. I mean, they are kind of the same thing, but you get what I mean, right? Now, for example, we are given that this is there and this is there. So this and this, right? So that means this and this. So if x is greater than y, right, and y is greater than z is also a possibility. So obviously x greater than y greater than z is absolutely fine. So this is completely true, right? Okay. Now, if z is greater than y, right, over here, if z is greater than y, right, and over here, if y is greater than x, right, so if z is greater than y and y is greater than x, so obviously z greater than y greater than x is also possible, right? So even this is true, right? Now let's suppose if x is greater than z greater than y, so if we take this part, z is greater than y, so z can be greater than y, definitely it can be, right? So z can be greater than y. Now we have to see, can x be greater than z, right? Can x be greater than z? So for example, let's take if z is equals to 4, right, and y is equals to 2. So z is greater than y, z is greater than y, absolutely fine. If over here we see that x is equals to 5, right, let's suppose. So over here x is greater than y, which means 5 is greater than 2, this is also fine. So over here we see that 5 is greater than 4 greater than 2, right? So we can say x is greater than z greater than y, right? So x greater than z greater than y, this is also true. So in this question, A, B, C, all the three paths are true. I hope this should be clear. So basically the crux of the question is that whenever you have, so basically we were given three things, right? So we both broke down the inequality into these two parts, this and this. So first part is x greater than y square. If this is given, we know that x can be greater than y, x can be less than y. Similarly, y square greater than z to the power 4. That means y can be greater than z or y can be less than z. And now it's a game of basically permutation combination. You can say this is whatever, and you can all get all these parts. So A, B, C, these three are the answers.